All right, so let's say now I'm asking you in the lab to tell me what % of Americans are very happy. Of Americans, not what % of respondents in this sample, right? I'm asking you a question about the population. What % of Americans are very happy? All right, so we're going to use the variable happy that asks for that. We're going to go to the rows and ask for this variable happy. And we're also going to go to the values and ask for that variable happy. We're getting the frequency distribution for that variable to find out the percentage of respondents that answered very happy. Now I'm going to filter out those that said don't know or didn't answer the question. So don't know out of there. Boom. Okay. Now we know that 700 said they're very happy. But we know the sample size is 2,344. Okay, we're going to need that, right? In n, our n is going to be 2,344. All right, now, this z value, if we want to be 95% confident of our answer, is going to be 1.96, right? If we wanted to be 99% confidence, that value would be 2.57. Okay. Anyway, we want to be 95%, so it's 1.96. Now we need to know what is the proportion of respondents in this sample that are very happy, right? We can get that by dividing this number by that, right? Or we can ask Google Sheets to do it for us. And it's 29.91. So it is basically 30%, right? That are very happy. It's basically 30% that are very happy, but we want to express that as a proportion. This is a percentage, and the proportion is just the percentage divided by 100. So the proportion is 0.30. Now, we know that there is 30% of Americans are very happy. Oh, not of Americans, of the sample, of this survey. But the question is, what % of Americans are very happy? So in order to talk about the population, we need to deal with this sampling error, right? Because this is a random sample, it has sampling error. So we need to calculate the margin of error and then the confidence interval. All right, the margin of error is this side of the equation, right? Z times the square root of that. Let's start calculating this part inside. Okay, so this would be equal to, I'm going to put 2 parentheses. So the P, which is 0.3, times 1 minus P, and P is 0.3, right? 1 minus 0.3, close the parentheses, and divide everything by n, which is 2,344. Let's see, 0.3 times 1 minus 0.3, all divided by 2,344. That's a very small number. That's fine. That's this part here. Now we're going to take the square root of that here. So that's going to be equal to the square root of that number, right? And that gives us that. This is the square root of that, right? Now we need to multiply by z. And that number is going to be the margin of error. So 1.96 times what the square root of that, right? All of that is 0.02. Okay, that's the margin of error. How do we interpret that? That's how far off we are from the population parameter. We may be from the population parameter, and we're 95% sure of that. Okay, now the confidence interval, again, we calculated by its 2 values, right? First, we're going to subtract that margin of error from P. So this is equal to 0.3 minus this 0.02. And then we're going to add it. So this will be equal to 0.3 plus 0.02. And that's our confidence interval. Now we can talk about the population. Now we can say that in the United States, in the population, between 28 and 32% are very happy. We are 95% sure of that. That the percentage, we're 95% sure that the percentage of Americans who are very happy is between 28 and 32%. In the sample, it was 30, right? But we may be off because of margin of error, because of sampling error, right? We may be off by 2%, 2 percentage points. So we are 95% sure that in the population, between 28 and 32% are very happy. Okay. So any questions?